Hello everyone. Today, we're looking at a very simple way so you can tell how long it takes to double your money at a given interest rate. We also look the other way around, which is what growth rate you need to achieve to have twice as much money in the time you have at your disposal. There are basically two ways to do this. There is a very precise, very accurate solution based on formulas and calculations. But I promised you simple things. And this is nothing but Rule 72. The method is very simple. You divide the 72 by the interest. That's it. Before we end this video with that much, let's take a closer look at a tiny example of it. Suppose there is a bank that gives a stable interest rate of 5% per annum. In this case, 72 divided by 5% per year, it takes 14,4 years for your money to be double that numerically. The same is true backwards. You have, for example, 10 years to achieve a given goal. You can easily calculate that 72 divided by 10 years equals 7. 2% per interest yearly must be a minimum to achieve this goal. But this is not only true for interest and yield. If you have a business and your goal is to have twice as much revenue in 5 years, you can calculate how much growth you need to achieve each year. The same is true if you have, say, a YouTube channel, and you want to know that if the number of subscribers increases at a given rate, when will you see twice as many subscribers on your channel? Obviously, if your goal is not to double, but to say quadruple, you can calculate it with Rule 72 by how much time it doubles twice. Let's look at the math behind it to see why Rule 72 works. I promise it won't be long, so if you don't like math, stay with me too. The calculation of the future value was already discussed in a previous video, a link to which can be found in the description. In a nutshell, the future value is nothing more but the present value multiplied by the appropriate power of the corresponding interest rate. So here, present value is the capital you now have and that we want to double. R is the interest rate by which your money increases, and N is the period for which your money works. This is usually determined in years. Obviously, FV as the future value is the amount that your capital will receive in the future. Replace this with a few simple numbers. The easiest way is to take the present value now for 1 unit of money. We can say we want 2 out of 1 forint. So the future value will be 2, the present value will be 1, and the formula will look like this. We can simplify this a bit. Since I promised I wouldn't go deeper into it, let's jump a big one in the next sort. If you are more interested in the details, ask your math teacher about this. Smile. Since we are looking for the exponent here, we call the natural logarithm for help, which we use further to get that 69,3 would have to be divided by the interest to get the doubling. Not 0,693,000, because you express interest in percent, so you multiply that by 100. However, this is very difficult to count, especially in head. So if you don't have a microchip brain, we'll look for a number that you can use more easily. Smart people have already done this for us, looking for one that is very close to this number, has a lot of dividers, which is why it is easy to use. And this is none other than 72. Rule 72 allows you to see for yourself how long it takes to double your money. You can see that as long as it takes a round of 36 years at a 2% annual interest rate, the time required is significantly reduced by 1% increments. At an annual interest rate of 12%, 6 years is enough. Note that interest is usually given annually. So if you want to see the solution in a month, use the interest accordingly. But only as often as capitalization takes place. In addition to being a very good little way to easily and simply calculate the time required for doubling in a friendly conversation, let's look at where you can use this. It doesn't take too much of a calculation that if you are offered an investment with a guaranteed 3% interest rate and the same one with only 4%, you obviously don't count, but accept the 4. Although, as you can see in the chart just now, there can be a serious discrepancy between the times of doubling. Specifically 6 years. But do you know the effect of increasing interest rates, yields, or growth rates on a larger scale? This can be important if you need to accumulate a certain amount at a certain time, or you just don't want to work more and more for capital. Rather, produce itself. Using Rule 72, you can easily see the impact of changing your interest rates. Let's say you inherited 10 million forints and for some reason you decide not to spend. It will come in handy for you in your old age as well. For the sake of example, be nearly 30 years old and set aside only that one amount for your retirement, and only increase it with interest. A lot of people keep their money in government securities for this purpose as well, being that the interest rate is higher than in the bank and it is safe as well. The interest rate of around 4% on government securities is completely realistic, at least in Hungarian forint. If you vote for security, at 4% interest, your money will double every 18 years. That 72 divided by 4% will be that 18 year. By the time you retire it will run down twice. The good news is that after the second round, not the first amount will be doubled again, so not another 10 million forint will be added, but because you do not touch it, the second will double with the help of compound interest. So out of the 10 million, it will be 40 million. If you can already think long-term anyway, you don't have to stay low. With an 8% increase, your money will double every 9 years, so until you retire, it will double 4 times instead of 2 times. Since the principles of compound interest are used here as well, it is also true here that the amount after doubling doubles again. Thus, by the end, there will be a significant difference. Although you only doubled the interest rate, it became 4 times the total. If you can achieve even higher growth, say a still realistically achievable 12%, then as I mentioned, 6 years is enough to have twice as much money. So by the time you retired, you had doubled it 6 times. If you look at it, simply by using the effect of compound interest and increasing the interest rate 3 times, your money has become 16 times more than in the first case. If I want to present this, it looks something like this. If you don't have that much time or you want to base it on a different interest rate, play with the numbers a bit. You will see how much difference a relatively minimal difference makes.